everyone. My topic today is Monitor WebLogic on Kubernetes using Oracle Enterprise Manager. My name is Yuta Katakatsu. I'm one of the product managers in the Enterprise Manager product management team. Here is today's agenda. First, we'll start with the introduction. What is Kubernetes and why that is important to WebLogic customers? Then there is WebLogic Kubernetes Operator, which is a utility that helps you manage the lifecycle of the WebLogic deployments in Kubernetes. We will then dive into how to monitor WebLogic deployed on Kubernetes, which is the main topic in the session. We will discuss the challenges and solution details. We will also talk about how secure the solution is, what happens when the pods are restarted, also how you can diagnose JVM. And lastly, limitation resources. What are the known issues and how you can learn more. It's been a while since we noticed that more and more organizations are moving their WebLogic into containers, especially Docker and Kubernetes as a part of the middleware modernization. But what are driving them to this direction? It is because the businesses are looking for agility and require quicker time to innovate and adapt to the market changes. This has become especially important after the pandemic that generated a lot of new requirements into IT because it changed the way we communicate, as well as many other aspects in the way we live. So the changes are happening out there and the businesses have to catch up and bring them into the solution as soon as they can. That is pushing the middleware to shift towards a lightweight infrastructure that has an ability and flexibility to adapt to the quicker and frequent changes in the market. Then what approaches there are? In high level, there are two different directions. One is to rewrite the application from scratch and replace with the new requirements and needs. It will bring the best business values, but this is an expensive option and takes some time to implement. So this will be a longer-term strategic project. Another approach that can be done tactically and likely more practical at this time is to re-platform the existing on-premise application, which is to move the application without making major changes but taking advantages of the cloud and container capabilities. As a result, many WebLogic customers have chosen to re-platform their existing WebLogic into Kubernetes at this time so that they can continue to use the existing investment while they can move into the better platform in the cloud. And WebLogic has a solution to help customers in that perspectives, migrating their existing applications to Kubernetes. That is the WebLogic Kubernetes Toolkit, which consists of 5 open source tools. And as the core of the solution, there is the WebLogic Kubernetes Operator. It provides automation to the WebLogic operations on Kubernetes, such as provisioning, lifecycle management, patching, scaling, and security when used together with other tools in the toolkit. Then what monitoring solutions there are? First of all, there is WebLogic Kubernetes Exporter that is one of the toolkit, which enables the collection of the WebLogic metrics and exports to Prometheus. Then you can use any dashboard utility such as Grafana to visualize the metric data. This has been suggested by the WebLogic team, so you may be familiar with it. Alternatively, or in addition, now you can use Application Performance Monitoring Service in the Oracle Cloud. This is a new Oracle Cloud service that collects traces and spans from the WebLogic instances and help you analyze application status and performance by providing end-to-end monitoring and diagnostics. So if you are new to Oracle's monitoring solutions, and especially if the application runs in Oracle Cloud, APM is the recommended solution. Another solution, which is the main topic in this presentation, is to use Oracle Enterprise Manager Cloud Control. For existing Enterprise Manager customers who are already familiar with EM, you don't have to go learn a new monitoring tool for the targets deployed in Kubernetes. You can use the same monitoring solution you have been using, which is the Enterprise Manager, for the WebLogic deployed on Kubernetes, along with your existing deployments in a traditional data center. And please be aware that there are conditions when you can use EM for the Kubernetes-based WebLogic targets. First of all, the domain has to be running in a hosted Kubernetes service in the cloud, such as Oracle Container Engine for Kubernetes, or OKE, or Azure Kubernetes Service, for example. This is because the approach which was discussed in this presentation uses a Kubernetes load balancer service that works in the selected cloud provider's environment. So this solution cannot be used in the on-premise Kubernetes where the hosted Kubernetes service is not available. And second, you must be using WebLogic Kubernetes Operator to manage the domain. And I would like to explore more details on the solution in this session. But before that, let's quickly recap what Kubernetes can do for you. Kubernetes is the most popular container orchestration solution available today in the market. It has a set of open source APIs that allows you to configure how and where you want to run or schedule to run your containers. Using Kubernetes, you can quickly run an instance of your application in a cluster and scale up and down based on your available resources. You can also extend the Kubernetes API with custom resources using custom resource definitions, or CRD, which allows you to introduce your own API into the cluster. In that sense, Kubernetes is portable, scalable, and extensible. As mentioned, WebLogic Kubernetes Operator helps you to migrate your WebLogic domain to Kubernetes. It extends the Kubernetes API and designed to accomplish the similar responsibilities to which a human operator would perform in a traditional data center deployment, such as starting and stopping the servers, for example. When the operator is installed, it creates a custom resource definition which defines the WebLogic domain type in Kubernetes. Once the domain type is defined, you can manage the domain using kubectl or kubectl commands, just like you do for any other Kubernetes resource type. The WebLogic operator always looks at the domain custom resource and tries to match the actual state to the desired state. So if one of the managed servers goes down, it tries to create another to match the number of replicas defined in a domain custom resource. Here is how it looks more realistically in the actual deployment. In this example, there is a WebLogic domain defined, an admin server, and also two managed servers, which are provisioned by the WebLogic operator in a Kubernetes cluster. And this is the environment we would like to monitor using Enterprise Manager. However, you cannot just directly install EM Agent on the WebLogic host as you would do in your on-premise deployment. Let's see what are the challenges here. If you follow Oracle recommendations, by default, WebLogic domain and the server components are created in a private subnet, with the access limited to its own virtual cloud network or VCN. There is no access allowed from outside the network, which means the Enterprise Manager that resides in the different VCN will not be able to install EM Agent remotely to the container host. Even in the case you manage to manually install the agent to the containers within the pods, there is still a problem as Oracle Management Service, or OMS, cannot access the agent because they are in a private subnet, while OMS needs to communicate with the agent bidirectionally. So there are security constraints in a Kubernetes setup that is purposely making the environment secure. And you will not want to change that unless you know a way not to compromise the security. Another challenge having EM agent in a pod is when managing the lifecycle of the agent. Kubernetes pods are transient in nature, so if a pod fails, the WebLogic Kubernetes operator automatically creates a new replica on the pod to continue the operation. However, in this case, EM agent won't be automatically reinstalled to this pod. You will lose the agent when the pods are recreated. So if you have an agent in a pod or in a container, you must go through the installation and discovery process manually every time the pods are destroyed and regenerated. So these are the problems or challenges you would expect when installing EM agent into the Kubernetes pods. And that is why we need a different approach. Next, let's talk about the solution. Our solution to resolve these problems is to use the Kubernetes Load Balancer service. To do so, first you will create a new private subnet within the VCN. Then within the subnet, create Kubernetes Load Balancer services that connect to the WebLogic servers. The way it works with the load balancer service type is that the service becomes accessible externally through a cloud provider's load balancer functionality. So in this case, underneath this picture, it creates a load balancer service in the Oracle Cloud, which will route the traffic to the cluster IP endpoints that is configured in a load balancer service, and use that service to connect to the WebLogic servers in the Kubernetes pods. And you will specify a port in each load balancer service that EM agent can access. In this example, the port numbers are same with those of the WebLogic servers. And that can be done by creating and applying a YAML file. In the port section, 7001 is specified for the port and the target port to connect to the admin server. There is also the port 30012 specified for the T3 channel, which is set for connecting to JVM. And please be aware, because the services are in the private subnet, the external ports are only accessible within the VCN. The next is to install an EM agent. Create the public subnet within the VCN. Then you can use SSH to push the agent binary from the Enterprise Manager console and remotely install the agent in the same VCN with the Kubernetes cluster. This way, it can connect to the load balancer services and get the metric data from the WebLogic servers. Lastly, configure the agent port so that it can communicate to the Enterprise Manager that is located outside of the VCN. Using this method, you can configure the EM agent to connect to the load balancer services instead of directly connecting to the WebLogic servers in the Kubernetes pods. And as briefly mentioned, the access to the ports are configured to the minimum required. The load balancer services are set up in a private subnet, and the access to them is restricted only within the VCN. So you will not be able to access the load balancers from the outside of the VCN. You can also restrict the access to the agent port 3872. This can be done by configuring the CIDR or CIDR in the public subnet, allowing access only from the Enterprise Manager host. So you can securely configure the access to the WebLogic servers as in this diagram, so that only through the Enterprise Manager you can access the information from outside of the VCN. Then what would happen when the pods or the worker nodes are restarted or regenerated? In this approach, monitoring continues because the EM agent do not reside in the pods. During the time when the pods are restarting, EM agent sees the targets are down. The target status is acknowledged as down in the Enterprise Manager console. When the pods are restored, the load balancers automatically reconnect to the new WebLogic server pod. The target status in the Enterprise Manager will back to up again. So reinstallation or reconfiguration of the EM agent is not required because it resides outside of the pod or the domain. Also, because Enterprise Manager regards the old server and the new server as the same target, the historical metric data of the target, which is already collected, is preserved. So you can continue to use the historical metric data of the analysis using the same target. Once you complete the setup, you can log into the Enterprise Manager console web user interface and discover the WebLogic domain and related targets using the standard Fusion middleware discovery process. Please note that because there's no agent installed in the WebLogic containers or pods, you need to use the EM agent, which you installed in the same VCN with the cluster, and remotely discover the targets. Also use the IP and the port from the load balancer service that is connected to the admin server as discovery parameters, as in this example screenshot displayed. This is the Fusion middleware discovery page in the Enterprise Manager console where I entered the IP and the port of the load balancer service. And upon the successful discovery, you'll be able to see the WebLogic targets discovered and started the monitoring in the Enterprise Manager console. And optionally, you can enable JVM diagnostics or JVMD on the WebLogic servers on Kubernetes and conduct deep dive analysis on their JVM. Using JVMD, you can find problems like the slowest request or the slowest method, which one is waiting for I/O or database calls, or which ones are using a lot of resources. So it has complete visibility into the JVM stack where you can drill down the performance issues to the method or even line number in the Java. And JVMD consists of a JVMD engine, which is a core analytical portion of the JVMD, and JVMD agents, which are the data collectors of the target JVM. Here you can manually deploy JVMD agent inside the WebLogic servers and collect real-time JVM monitoring data. The agent transmits the collected data to the JVMD engine directly using one-way HTTPS connection. And please note that JVMD does not use an EM agent because it has its own channel to communicate with Enterprise Manager. And as a limitation to this approach, the JVMD agent deployment will be lost when the pod is regenerated. Therefore, reinstallation of the JVMD agent must be repeated every time when such event happens. So if you want to have the JVMD agent persist in the WebLogic server, you can deploy it in the Docker image of the WebLogic so that the JVMD agent is pre-deployed when a pod is created. But if you don't have access to the Docker image, or if you're unable to change the image, this can be a workaround. And because Enterprise Manager monitors the targets from the agent installed in a remote location instead of deploying the agent directly into the host, there are some limitations. For example, WebLogic target metrics and configurations are collected only from the JMX space, which means script-based or file-based metrics or configurations cannot be monitored because they require a local agent in a target host. An example for this is the log file metrics, as they open log files in the file systems and read the contents. We will not be able to do this because there is no agent deployed in the target host. On the other hand, most of the WebLogic target metrics are JMX based, so you still should be able to effectively monitor WebLogic targets using this model. Features that require OMS to log on to the target host are not available. This includes starting and stopping WebLogic servers, patch automations, provisioning, and also the WST job submission. And with respect to the lifecycle management features, it is recommended to use the options provided by the WebLogic Kubernetes Operator because it has the exact capabilities which fulfills this purpose. Also, features which require OMS to directly log on to WebLogic Administration Console are not available. On the other hand, you can directly log on to the WebLogic Admin Server Console web user interface to use these features. And as discussed, JVM diagnostics can be set up manually. However, redeployment is required when the pods are regenerated. And we have hands-on workshop available in the Oracle Live Labs, which covers the topics discussed in today's session. This is 1 hour and 40 minutes workshop that you can try the deployment of the WebLogic on Kubernetes in the Oracle Cloud and enable the monitoring with Enterprise Manager. It is free of charge when you are using Oracle Free Trial. The workshop consists of 8 tutorials with step-by-step instructions, such as creating a private subnet in Oracle Cloud or configuring Kubernetes load balancer service. You can also learn how to set up EM agent, discover WebLogic servers using EM console, verifying the target monitoring at the pod restart, and also how to enable JVMD in the Kubernetes. As mentioned earlier, you can also use the Oracle Cloud APM service as an alternative or in addition to monitor WebLogic deployed on Kubernetes. We have a workshop that you can experience with the step-by-step tutorials for APM on WebLogic Kubernetes. This is the end of the recording. Thank you for watching.